First of all, we will see the history of the Android. What is Android? Android is a software platform and operating system for mobile devices. Android is based on the Linux kernel, developed by Google and later the Open Handset Alliance (OHA). Android Incorporated was founded in 2003. It was founded in Palo Alto, California, United States in October 2003 by Andy Rubin, co-founder of Danger, Nick Sears, vice president at T-Mobile, and Chris White. Android allows writing managed code in the Java language. Possibility to write applications in other languages and compiling it to ARM native code. Unveiling of the Android platform was announced on November 5, 2007 with the founding of OHA. Android is not a single piece of hardware. It's a complete, end-to-end software platform that can be adapted to work on any number of hardware configurations. Everything is there, from the bootloader all the way up to the applications. Android uses Linux for its device drivers, memory management, process management, and networking. The next level up contains the Android native libraries. They are all written in C/C internally, but you'll be calling them through Java interfaces. In this layer you can find the Surface Manager, 2D and 3D graphics, media codecs, the SQL database SQLite, and a native web browser engine WebKit. Dalvik Virtual Machine. Dalvik runs DEX files, which are converted at compile time from standard class and jar files. We can only hope that the next versions of Android have overcome the actual limitations and that the future possibilities became a reality. Android versions. Now let's see versions of the Android. Android has seen a number of updates since its original release. These updates focus on fixing bugs as well as adding new features. The most recent released version of Android are Android Robot, Android Eclair, Android Froyo, Gingerbread and Android Honeycomb. v2.0 Cupcake. On October 26, 2009, the Android 2.0 SDK codenamed Eclair was released, based on Linux kernel 2.6.29. Changes included expanded account sync, allowing users to add multiple accounts to a device for email and contact synchronization, Exchange email support, with combined inbox to browse email from multiple accounts in one page, Bluetooth 2.1 support. Ability to tap a contact's photo and select to call, SMS, or email the person, ability to search all saved SMS and MMS messages, with delete oldest messages in a conversation automatically deleted when a defined limit is reached, numerous new camera features, including flash support, digital zoom, scene mode, white balance, color effect and macro focus. Improved typing speed on virtual keyboard, with smarter dictionary that learns from word usage and includes contact names as suggestions. v2.2 Froyo. On May 20, 2010, the Android 2.2 Froyo SDK was released, based on Linux kernel 2.6.32. Its features included speed, memory, and performance optimizations, additional application speed improvements, implemented through JIT compilation, integration of Chrome's V8 JavaScript engine into the browser application, support for the Android cloud-to-device messaging C2 decimeter service, enabling push notifications. Improved Microsoft Exchange support, including security policies, auto-discovery, gal lookup, calendar synchronization and remote wipe. improved application launcher with shortcuts to phone and browser applications, USB tethering and Wi-Fi hotspot functionality, added an option to disable data access over mobile network, updated market application with batch and automatic update features. V2.3 Gingerbread. On December 6, 2010, the Android 2.3 Gingerbread SDK was released, based on Linux kernel 2.6.35. Changes included updated user interface design with increased simplicity and speed, support for extra large screen sizes and resolutions, native support for SIP VoIP internet telephony, faster, more intuitive text input in Virtual Keyboard, with improved accuracy, better suggested text and voice input mode. Enhanced copy/paste functionality, allowing users to select a word by press hold, copy, and paste. Support for near-field communication NFC, allowing the user to read an NFC tag embedded in a poster, sticker, or advertisement. New audio effects such as reverb, equalization, headphone virtualization, and bass boost. New download manager, giving users easy access to any file downloaded from the browser, email, or another application. Support for multiple cameras on the device, including a front-facing camera, if available. V3.0 Honeycomb. On February 22, 2011, the Android 3.0 Honeycomb SDK, the first tablet-only Android update, was released, based on Linux kernel 2.6.36. The first device featuring this version, the Motorola Xoom tablet, was released on February 24, 2011. Changes included optimized tablet support with a new virtual and holographic user interface. Added system bar, featuring quick access to notifications, status, and soft navigation buttons, available at the bottom of the screen. Added action bar, giving access to contextual options, navigation, widgets, or other types of content at the top of the screen. Simplified multitasking. Tapping recent apps in the system bar allows users to see snapshots of the tasks underway and quickly jump from one app to another. Redesigned keyboard, making typing fast, efficient and accurate on larger screen sizes. Simplified, more intuitive copy/paste interface. Android logo. The Android logo was designed with the Droid font family made by Ascender Corporation. Android green is the color of the Android robot that represents the Android operating system. Features of the Android: handset layouts, storage, connectivity, messaging, multiple language support, web browser, Java support, media support, streaming media support, additional hardware support, development environment, market, multi-touch, Bluetooth, video calling, multitasking, voice-based features, tethering. Application framework enabling reuse and replacement of components. Dalvik virtual machine optimized for mobile devices. Integrated browser based on the open-source WebKit engine. Optimized graphics powered by a custom 2D graphics library. 3D graphics based on the OpenGLES 1.0 specification. SQLite for structured data storage. Media support for common audio, video, and still image formats, GSM telephony, Bluetooth, Edge, 3G, and Wi-Fi, camera, GPS, compass, and accelerometer. Rich development environment including a device emulator, tools for debugging, memory and performance profiling, and a plugin for the Eclipse IDE. Android architecture. The following diagram shows the major components of the Android operating system. Libraries. Android includes a set of C/C libraries used by various components of the Android system. These capabilities are exposed to developers through the Android application framework. Some of the core libraries are listed below. System C library, a BSD-derived implementation of the standard C system library, tuned for embedded Linux-based devices. Media libraries, based on Packet Video's OpenCore. The libraries support playback and recording of many popular audio and video formats, as well as static image files, including MPEG-4, H.264, MP3, AAC, AMR, JPG, and PNG. Surface Manager manages access to the display subsystem and seamlessly composites 2D and 3D graphic layers from multiple applications. libWebCore, a modern web browser engine which powers both the Android browser and an embeddable web view, SGL, the underlying 2D graphics engine. 3D libraries and implementation based on OpenGLES 1.0 APIs. The libraries use either hardware 3D acceleration or the included, highly optimized 3D software rasterizer, free type bitmap and vector font rendering. SQLite, a powerful and lightweight relational database engine available to all applications. Android runtime. Android includes a set of core libraries that provides most of the functionality available in the core libraries of the Java programming language. Every Android application runs in its own process, with its own instance of the Dalvik virtual machine. Dalvik has been written so that a device can run multiple VMs efficiently. The Dalvik VM executes files in the Dalvik executable format, which is optimized for minimal memory footprint. The VM is register-based, and runs classes compiled by a Java language compiler that have been transformed into the DEX format by the included EX tool. Android runtime. The Dalvik VM relies on the Linux kernel for underlying functionality such as threading and low-level memory management. Linux kernel. Android relies on Linux version 2.6 for core system services such as security, memory management, process management, network stack, and driver model. The kernel also acts as an abstraction layer between the hardware and the rest of the software stack.
Now we talk about Android development. Android is a Linux-based operating system for mobile devices such as smartphone and tablet computers. It is developed by the Open Handset Alliance and led by Google. Google purchased the initial developer of the software Android in 2005. The Android distribution in 2007 was announced with the founding of the Open Handset Alliance. Google released the Android code as open source under the Apache license. The Android open source project is tasked with maintenance and further development of Android. Android Inc. founded in 2003. Android Inc. was founded in Palo Alto, California, United States in October 2003 by Andy Rubin, Rich Miner, Nick Sees, and Chris White to develop. Android Inc. acquired by Google. Google acquired Android Inc. in August 2005, making Android Inc. a wholly owned subsidiary of Google Inc. Development accelerates. At Google, the team led by Rubin developed a mobile device platform powered by the Linux kernel. Speculation about Google's intention to enter the mobile communications market continued to build through December 2006. Open Handset Alliance. The goal of Open Handset Alliance is to develop open standards for mobile devices. On the same day, the Open Handset Alliance also their first product, Android, a mobile device platform built on the Linux kernel version 2.6. Hardware running Android. The main supported platform for Android is the ARM architecture. The Android OS can be used as an operating system for cell phones, netbooks, and tablets, including the Dell Streak, Samsung Galaxy Tab, TV, and other devices. Software development. The Android Software Development Kit includes a comprehensive set of development tools. These include a debugger, libraries, a handset emulator, documentation, sample code, and tutorials. Version history. Android has seen a number of updates since its original release, each fixing bugs and adding new features. Each version is named in alphabetical order after desert. Features: storage, handset layouts, connectivity, multiple language support, Java support, streaming media support, additional hardware support, development environment, video calling, voice-based features, storage, messaging, web browser, media, support, market, multi-touch, Bluetooth, and multitasking. Finally, as of February 2012, there were more than 450,000 apps available for Android. Android was listed as the best-selling smartphone platform worldwide in Q4 2010 by Canalys with over 300 million Android devices in use.
Now let's talk about the Android market. Android market is Google's answer to Apple's App Store, allowing for an organized listing and easy way to download applications made for the specific phone operating system. With the release of the Nexus 1, phones with Google's Android OS are expected to greatly expand, and with new users, will come a new hunger for applications. Google has stated from the start that the vision for Android market is not only for users, but as a way to attract developers. Such was the reasoning in choosing the term market over store. Android market is not so much a store run by Google, but a market made to bring together application developers and Android OS phone users. History of Android market. The first announcement of the coming of Android market was on August 28, 2008, and it was made available as a beta version on 2 months later on October 22, 2008. Android market began by offering only free applications during beta testing, with the full purchase system being implemented in the US and UK in February of 2009. 1 month later, in March of 2009, 2,300 applications were available to users. By the end of 2009, the applications available on Android market had grown to over 20,000. This number put it ahead of Windows Mobile market, but still far behind the iPhone App Store at 100,000 applications. Even though Android market falls short compared to the application store, proponents are quick note that they reached the 20,000 mark much faster than the App Store. These same proponents also say that many of the App Store's 100,000 applications are only duplicates of already existing applications, and they serve only to make it more difficult to wade through for the average consumer. On March 17, 2009, about 2,300 applications were available in the market, according to T-Mobile Chief Technical Officer Cole Broadman. On May 10, 2011, during the Google I/O, Google announced that Android market listed 200,000 apps, and had clocked 4.5 billion apps installed. On December 31, 2010, the Android market reached the 200,000 app milestone. On February 2, 2011, Google presented a new web client, providing access to the market via PC. In May 2011, Google added new app lists to Android market, including top grossing apps, top developers, trending apps, and editors' recommendations. In July 2011, Google introduced a redesigned interface with a focus on featured content, more search filters, and book sales and movie rentals. In September 2011, the Motorola Xoom tablet received an update that brought the redesigned Android market to an Android 3X honeycomb-based device. In November 2011, Google added a music store to the Android market. By the end of 2011, the applications available on Android market had grown to over 380,297. And by the end of February 2012, there were more than 450,000 applications available on the Android market. Comparisons to competitors. Android market features 67% free of charge apps, the highest percentage of any major app store, closely rivaled by Windows Phone Marketplace at 61%. By comparison, the Apple App Store offers only 37% of their apps free of charge. Priced applications. Developers of software receive 70% of the application price, with the remaining 30% distributed among carriers and payment processors. Revenue earned from the Android market is paid to developers via Google Checkout merchant accounts. Now let's see the user availability of the Android. As of May 2011, users in 131 countries can purchase paid applications from Android market. Some carriers offer direct carrier billing for Android market app purchases. Purchases of unwanted applications can be refunded within 15 minutes of the time of download. There is no requirement that Android applications be acquired from Android market. Users may download Android applications from a developer's website, or through a third-party alternative to Android market. These are some Android market devices. Acer Liquid A1, Arcos 5 Internet Tablet, Barnes & Noble Nook, Dell Mini 3i, HTC Dream, Magic, Desire, Hero, and Tattoo. In addition to these, there are games such as Arcade and Action, Brain and Puzzle, Cards and Casino, Casual, Live Wallpaper, Racing, Sports Games, Widgets. And under applications, there are Android applications in the categories such as Business, Comics, Communication, Education, Entertainment, Finance, Health and Fitness, Libraries, Demo, and many more. Who developed the Android market? In the beginning, only developers located in the US and the UK were allowed to publish applications that carried a price tag. In April of 2009, Google announced plans to allow developers in Austria, France, Germany, Netherlands, and Spain to publish their priced Android apps and, making it on their word, soon afterward these countries had the ability to expand Android market with their applications. Soon afterward, Japanese and Italian developers were added to the list. Australia, strangely, is absent from the list of countries that are allowed to publish priced applications, and there has been much speculation about the reasoning behind this decision. As of today, the reasons why Australia has not been added remain a secret. Android app developers, no matter the country, do have one advantage over iPhone app developers, and that is the fact that distribution of Android apps is not limited to Android market. iPhone apps can only be distributed and purchased through App Store, but Google allows Android apps to be distributed from any source, so many developers make Android apps available on their own website or on secondary Android application websites. Tethering applications on Android market. One controversy sparked by Android market is the availability of applications that allow tethering of mobile devices to laptop or desktop computers. Tethering is a means by which a mobile device acts as a modem to provide internet access to a tethered computer. This type of internet access undercuts the separate internet service available to customers, and tethering a mobile device in such a way is in direct violation of the T-Mobile user agreement. As a result, Google initially pulled all tethering applications off of Android market. Later, however, they were restored to all other carriers except T-Mobile. Let's discuss about the Android applications now. Android applications are written in the Java programming language. The Android SDK tools compile the code, along with any data and resource files, into an Android package, an archive file with an .apk suffix. All the code in a single .apk file is considered to be one application, and is the file that Android-powered devices use to install the application. Application components are the essential building blocks of an Android application. Each component is a different point through which the system can enter your application. Not all components are actual entry points for the user, and some depend on each other, but each one exists as its own entity and plays a specific role. Each one is a unique building block that helps define your application's overall behavior. There are 4 different types of application components. Each type serves a distinct purpose and has a distinct life cycle that defines how the component is created and destroyed. Activities. An activity represents a single screen with a user interface. For example, an email application might have one activity that shows a list of new emails, another activity to compose an email, and another activity for reading emails. Although the activities work together to form a cohesive user experience in the email application, each one is independent of the others. As such, a different application can start any one of these activities. For example, a camera application can start the activity in the email application that composes new mail, in order for the user to share a picture. Services. A service is a component that runs in the background to perform long-running operations or to perform work for remote processes. A service does not provide a user interface. For example, a service might play music in the background while the user is in a different application, or it might fetch data over the network without blocking user interaction with an activity. Another component, such as an activity, can start the service and let it run or bind to it in order to interact with it. Content provider. A content provider manages a shared set of application data. You can store the data in the file system, an SQLite database, on the web, or any other persistent storage location your application can access. Through the content provider, other applications can query or even modify the data. For example, the Android system provides a content provider that manages the user's contact information. As such, any application with the proper permissions can query part of the content provider to read and write information about a particular person. Broadcast receivers. A broadcast receiver is a component that responds to system-wide broadcast announcements. Many broadcasts originate from the system. For example, a broadcast announcing that the screen has turned off, the battery is low, or a picture was captured. Applications can also initiate broadcasts. For example, to let other applications know that some data has been downloaded to the device and is available for them to use. Although broadcast receivers don't display a user interface, they may create a status bar notification to alert the user when a broadcast event occurs. More commonly, though, a broadcast receiver is just a gateway to other components and is intended to do a very minimal amount of work. For instance, it might initiate a service to perform some work based on the event. Application framework. By providing an open development platform, Android offers developers the ability to build extremely rich and innovative applications. Developers are free to take advantage of the device hardware, access location information, run background services, set alarms, add notifications to the status bar, and much more. Developers have full access to the same framework APIs used by the core applications. The application architecture is designed to simplify the reuse of components. Any application can publish its capabilities and any other application may then make use of those capabilities. This same mechanism allows components to be replaced by the user. Underlying all applications is a set of services and systems, including a rich and extensible set of views that can be used to build an application, including lists, grids, text boxes, buttons, and even an embeddable web browser. Content providers that enable applications to access data from other applications, or to share their own data. A resource manager, providing access to non-code resources such as localized strings, graphics, and layout files. A notification manager that enables all applications to display custom alerts in the status bar. An activity manager that manages the lifecycle of applications and provides a common navigation backstack. Best email clients? K9 Mail Android app is an open-source email client for Android with multi-folder sync, email signatures, BCC to self, return address configuration, keyboard shortcuts, exchange support, message flagging, IMAP deletes, saving attachments, configurable notifications and more. K9 Mail Android app is one of the best email clients for Android. It's loaded with every email feature you could think of except Active Sync. By far a better replacement over the default email client created by Google. I personally like the IMAP folder synchronization, signatures and the ability to multi-manage several emails and boxes from a mobile device. Here is the complete list of features. Send and receive. Configure to IMAP, POP3, and Web.avi email protocols. Search multiple inboxes. Swipe for previous, next emails.
you think Android is so popular? In a very short time, Google's mobile operating system Android has become the #1 choice for smartphones. Google's Android has overtaken Symbian and Windows Mobile in terms of number of users. Research agencies across the world have confirmed this. But how did Android manage this in just a few years? It's simply because of these reasons. This is the main reason. Android is free. Android, since the day it was launched, has been available free of cost, and Google made it clear that it will be free in future as well. The OS caught the attention of manufacturers across the world, and many initially adopted it for low-cost smartphones. Seeing the huge response of the buyers to the Android-based phones, many equipment manufacturers joined the league, and more are joining every day. Therefore, the free nature of this operating system helped in reducing cost, thereby helping buyers too. Second reason is that Android is an open source. Unlike other operating systems that are protected by lots of copyrights, Google chose to keep Android open for all. By doing this, the company got many programmers from around the globe to develop applications, while keeping its liabilities to a minimum. With many brains working on the system, newer and newer ideas were incorporated, which in turn helped in making Android a preferred choice. Third reason is that Android is open for customization. Unlike Windows or any other mobile operating system, device manufacturers are free to modify Android as per their needs. Users enjoy much-needed flexibility and ease of use because manufacturers are now able to modify anything and everything they need to make the experience a pleasant one. Another reason is that Android has large number of applications. Android market created an opportunity for millions of application developers around the globe to show their skills and come up with newer applications for Android phones. Its users therefore have a wide variety of applications to choose from and can customize their phones for a personal experience. Android opened numerous possibilities for both device manufacturers and application developers, while helping to reduce the cost of smartphones, thus making them accessible to the common man. Today, Android smartphones such as Micromix Android A60 are available at only 6,500 rupees. And even high-end phones, including Dell's Venue, are available at about 30,000 rupees. Summing it up, Android has taken user experience to the next level while keeping the prices of smartphones well within the reach of the common man, and that is why Android has become the #1 choice among smartphone users.